Quantum numbers can be defined as a set of four numbers that provide the complete information about an electron in an atom. In other words, quantum numbers can be regarded as the address of an electron, which helps to determine its location, energy, orientation, and spin of the electron in the atom. Thus, the quantum numbers can be used to describe the location of any one electron within an atom. There are four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. The first quantum number is the principal quantum number, denoted by the symbol n. This quantum number provides information regarding the shell number in which the electrons are located. Also, the energy of the electron located in a particular shell. The shell number is represented by the symbol n. N equal to 1 represent the first shell, that is K. N is equal to 2 represent the second shell, that is L. N is equal to 3 represent the third shell, that is M. And n is equal to 4 represent the fourth shell, n. The energy of the electrons increases with the increase in the value of n. This means that the electrons in the K shell will have the lowest energy, the electrons in the L shell will have slightly more energy, and so on. The maximum number of electrons in each shell is given by the equation 2n square, where n represents the shell number. So for the first shell, that is K, the maximum number of electrons is given by 2 into 1 square, that is 2. For the second shell L, the maximum number of electrons is 8. For the third shell M, the maximum number of electrons is 18. And for the N shell, the maximum number of electrons is 32. The shells are also called energy levels. The second quantum number is azimuthal quantum number. It is represented by the symbol L. It is also known as orbital quantum number. This quantum number determines the subshell to which each electron belongs. The shells are further divided into subshells, and the azimuthal quantum number L gives information about the number and shape of these subshells. The shells can be subdivided into subshells. The maximum number of subshells is equivalent to the shell number. For example, when n is equal to 1, that is the first shell, only one subshell is possible. And when n is equal to 2, that is for the second shell, only two subshells are possible. There are four different types of subshells. These various types of subshells are denoted by the letters S, P, D, and F. Each subshell has a maximum number of electrons which it can hold. S subshell can hold a maximum of 2 electrons, P can hold a maximum of 6 electrons, D a maximum of 10 electrons, and F a maximum of 14 electrons. The S subshell is of the lowest energy subshell, and the F subshell is the highest energy subshell. The azimuthal quantum number L can be any integer between 0 and n minus 1, where n is the principal quantum number or shell number. For example, if n is 3, the L values can be either 0, 1 or 2. This means that for the third shell, 3 subshells are possible. The subshells corresponding to each L values and their shapes are given here. When L is 0, the corresponding subshell is S, and the shape of S subshell is spherical. When the L value is 1, the corresponding subshell is P, and the shape of P subshell is dumbbell. When the L value is 2, the corresponding subshell is D, and the shape of D subshell is double dumbbell. The subshell corresponding to L value of 3 is F, and the shape of F subshell is complex. The subshells corresponding to each shells are given here. The equation to find the number of subshell is 0 to n minus 1, where n is the shell number. So for the first shell, that is K, where the n value is 1, the number of subshells are given by 0 to 1 minus 1, that is 0 itself. And the subshell corresponding to L value of 0 is S. So the subshell is represented as 1s. The term 1s represents S subshell of first shell. Similarly, for the second shell, that is L, where the n value is 2, the number of subshells are given by 0 to 2 minus 1, and the values are 0 and 1. The subshell corresponding to 0 is S, and the subshell corresponding to 1 is P. So the second shell has got two subshells, and they are 2S and 2P. 2S represent S subshell of second shell, and 2P represent P subshell of second shell. Similarly, for the third shell M, where the n value is 3, the number of subshells are given by 0 to 3 minus 1, and the values are 0, 1 and 2. The subshell corresponding to 0 is S, 1 is P, and 2 is D. And the subshells are named as 3S, 3P and 3D. Similarly, for the fourth shell, that is N, where the N value is 4, the subshells are given by 0 to 4 minus 1 and the values are 0, 1, 2 and 3 and the subshells are named as 4S, 4P, 4D and 4F. This image describes the number of subshells present in each shell. The third quantum number is the magnetic quantum number represented by the symbol M. This quantum number gives information about the orbitals. This quantum number can have values ranging from minus L to plus L. Each subshell is further divided into orbitals. An orbital is defined as the region of space in which an electron can be found. Only 2 electrons are possible per orbital. The number of orbitals present in each subshell is given by the equation 2L plus 1. Thus, for the S subshell, where the L value is 0, the number of orbitals is given by 2 into 0 plus 1, that is equal to 1. This means that the S subshell has got only one orbital. For the P subshell, where the L value is 1, the number of orbitals is given by 2 into 1 plus 1, that is equal to 3. This means that the P subshell has got 3 orbitals. For the D subshell, where the L value is 2, the number of orbitals is given by 2 into 2 plus 1, that is equal to 5. This means that the D subshell has 5 orbitals. Similarly, for F subshell, where the L value is 3, the number of orbitals is given by 2 into 3 plus 1, that is 7. This means that F subshell contains 7 orbitals. This table gives the complete information regarding the 3 quantum numbers, that is principal quantum number, azimuthal quantum number and magnetic quantum number. The values of magnetic quantum number ranges from minus L to plus L. For example, let us consider the third shell. The third shell has got 3 subshells. They are 3S, 3P and 3D. The 3S, being an S subshell, has got only one orbital and its value is 0. Only 2 electrons can enter in an orbital, so the maximum number of electrons in the 3S subshell is 2. The 3P, being a P subshell, has got only 3 orbitals. The L value of P is 1 and the values of the orbitals are ranging from minus L to plus L and they are minus 1, 0 and plus 1. Since there are 3 orbitals and each orbital can occupy 2 electrons, 3P can accommodate 6 electrons. Similarly, the 3D, being a D subshell, has got 5 orbitals. The L value of D is 2 and the values of the orbitals are ranging from minus 2 to plus 2 and they are minus 2, minus 1, 0, plus 1 and plus 2. Since the 3D subshell has got 5 orbitals and each orbital can accommodate a maximum of 2 electrons, the total number of electrons in 3D subshell is 10. This picture describes the shells, the subshells and the number of orbitals present in each subshell. The fourth quantum number is spin quantum number. It represents the spin state of the electrons in an orbital. It is represented by the symbol M subscript S. The values of spin quantum numbers are plus 1 by 2 and minus 1 by 2. The value plus 1 by 2 represent the spin along the clockwise direction, whereas the value of minus 1 by 2 represent the spin along anti-clockwise direction.